I would like to invite Jörg, Bauke and Pablo on stage to discuss the technical view on how to make all this thing happen. Please come on stage, please. And give them well. Bauke. Pablo.
Nice to meet you.
Jörg.
Good to see you.
Good to see you. Please take a seat.
Any particular order? No.
Well, we have all heard the challenges, we heard the perception, but you're the ones who make it happen, basically. Some people say, yeah, everything is in the cloud, so why don't we need a data center? But we know that it's all about the technology, the infrastructure, and also the developments and innovation that we need to have to constantly follow the market, and especially now with AI. So, short, to start, what is from your perspective, seeing the biggest bottleneck on scaling towards the AI infrastructure? Jörg, can I start with you?
Sure, you can. The biggest bottleneck, I think power is something that we talked about here quite a lot. We're looking at cooling solutions out there in order to promote the AI development here also in Europe. The whole topic about liquid cooling is something that is coming up, where I have to say, looking at the US, we already quite there. There are a lot of data centers that are being built and have full-blown liquid cooling deployed. Here in Europe, there is a lot of discussion around liquid cooling, but I have not seen a real breakthrough. I'm personally a big fan of liquid cooling. I always thought that this is the best solution out there, involved in it since quite some time now. But people are very conservative, and we have seen a lot of challenges in the US by introducing it at scale, and it caused some mistakes that were made, which were very costly, because there is a certain risk with liquid cooling, right? We going directly into the chip, and I personally have always thought if liquid cooling is coming at a breakthrough, that we will see the mechanical cooling needs reducing or even going away, because we can operate with much higher temperatures.
So in a positive note, we can do it quicker, and we can avoid the mistakes that were made in the US.
I wanted to get to this point.
Very good. Pablo, if you look at sort of like the bottlenecks, what is your view on that?
So I have a European view, and I don't think there is only one bottleneck now in the industry. We're facing few of them. When it comes to power, I think power is available. For me, the bottleneck is access to that power and how we can expand that power capacity afterwards. So this is the main concern. Also, there are, depending on the regions, for sure, permitting is quite a challenge, and we see many projects that are taking longer than expected because we don't get the right permitting on time, and this is something that we need to address for sure. For me, there's a long-term bottleneck that we are not seeing now, but in the future will be definitely the scarcity of talent, which at the end of the day we need to design, build, and operate the data centers in a different way. And I really foresee that in the future it's going to happen that scarcity of talent to manage those data centers is going to be a bottleneck to keep on growing. Maybe not now, but in the future for sure it would be an issue.
So several bottlenecks.
Yeah.
And Bauke, from your perspective?
Yeah, so mainly from the technical side, because I'm really as a technologist. So inside the data center, there's a challenge, or not so much of a bottleneck. I see it as a challenge because they can be resolved. So the first one is, how do you get the power in? And then the second one is, how do you get the heat out? And I think my colleagues have been explaining that very clearly already. Outside the data center, the bottlenecks actually start to multiply very quickly. This whole event is almost focusing now on the availability of power. Everybody's talking about, and it's the buzzword that's going around. The key thing is that what you have to consider is that the power actually is available. Most of the countries in the FLAP-D countries, where they have sufficient supply of generation capacity. The bottleneck is in the transportation of how do you get it to the location of your data center. So where can you actually plug in? And the basic concept where you have to trying to rethink building your data centers in that area is how do you interface with the power infrastructure? And then the word flexibility is actually becoming key. Whereas traditionally data centers have been building themselves or have been built with a very rigid power approach, so you almost have a continuous base load, which was nice when we were looking into the pre-renewables era. So when we all had traditional generation with fossil fuels, you had a top-down approach, so you're generating electricity at high voltage and it trickles down to all your users. And then rigidity of power, so a constant load was very nice because a coal power plant really likes to run at continuous power all the time. Now we're talking about renewables, and the one thing about renewables is that they're unpredictable and they're not always available. So you have to try to adapt your data center approach in that same mindset. How do I deal with flexibility of power? How do I can help the grid operators offload at times when there is an abundance of green electricity at certain times? And how can I scale down my operations at times when there's shortage?
Yeah. All right. If you look at, thank you. If you look at the change towards different infrastructure, you now hear AI ready. We heard that from a long time ago with the chips and the Intel inside and the ready chips, Pentium ready, or from that area. But if you look at, if you're now going to build a data center, Jörg, and if you want to be ready for AI, what do you need to do? Because we're still in a sort of like in-between phase. What is the best advice from your perspective to anyone who is building a data center now or is planning to build a data center now?
I would say that AI ready equals high density, right? The machines that are being used for AI to develop these large language models, they are high powered, they need a different type of cooling, so building the bridge again over to the liquid cooling approach, that is definitely the way to go. However, I don't believe that we will go away from air cooling, for example, right? So this is a discussion that is ongoing. But AI ready means I'm building a data center that can be partially liquid cooled. That's what I would do, even so I'm more from the side of providing cooling solutions. And a lot of conversations I had with data center operators, that's what they are doing today, to say, yes, I'm building a traditional data center, but I allow certain areas where I can have higher density being installed. And there are solutions out there, like, for example, rear door heat exchangers. So you have a typical layout of a data center. You want to allow an area where you increase your performance by implementing, for example, liquid cooling solutions, but you may have a X amount of residual air cooling needs, and you don't want to disturb the overall layout of your data center, so you add certain technologies in order to be kind of room neutral in these areas. But I would definitely say AI equals more or less liquid cooling solutions.
Yeah, and you as a supplier, as a provider of these kind of systems, are you also, Bauke was talking about flexibility. How flexible are you nowadays if with this in mind? Is flexibility also now key part of your solution?
Oh, absolutely, absolutely. There's not really a standard out there. Yes, of course. We are talking about standards, but each of our customers have certain ideas how they would like to address the challenges that they are faced with. For example, it depends on the end user, on the application, in which way the machine is to be operated. And if we look, for example, into co-locations, they are all of a sudden faced to do it one way and the other way. So we have to be flexible as a provider of the equipment that makes it happen. So there is a lot of customization. And I think we will also see changes more rapidly coming our way, because technology is changing, the density on the chips are going up. The question is how to address this in the most flexible way without changing infrastructure over and over again.
Yeah.
In my opinion, flexibility is very important. I mean, it's a mandate. Now we see, we all talk about AI, but we still see commercial cloud development, and we will have to manage hybrid ecosystem and hybrid infrastructure to be deployed. And for that, we need to get this compromise between the liquid cooling solution, air cooling solution, traditional solutions with new solutions, and definitely flexibility is mandatory now. And also, we need to be very close to, as well, to what is the trend on the OEM or the chip manufacturers, so we can foresee and design the data centers that will come in few years into reality, and being able to cope that technology demand that we foresee. So definitely flexibility is becoming a...
As Schneider, you're overseeing sort of like the whole facility with solutions that you are providing. Is every element affected by this change?
For me now, and indeed, I left the data center industry for a couple of years, and then I'm back. And I realized that in 2 years, this industry has been reshaped and totally disrupted. And we cannot continue to deploy data center with considering the data center is the sum of multiple systems. The systems are totally interconnected. You cannot design your power electrical distribution without taking into consideration how you're going to cool down the racks. And so you need to have a holistic view on the data center. So for me, it's fundamental that we break the silos inside the data center. We look at the data center as a holistic system, but not only inside the data center, outside also this data center, it has to be integrated into the grid, into the rest of the community, because it's a fundamental infrastructure for the entire grid and the entire society.
Perfect. And Bauke, you're also a lot of experience in outside the data center arena. But coming back to your flexibility part and looking at the AI developments, you're seeing on the one hand larger facilities, but to provide flexibility for larger facilities, how should we solve that? Because that's a lot of batteries, to put it simply.
Batteries are probably somewhere in the answer there, yes. I think it will be the first technology that most data center developers will be trying to grab into, or to try and partner up with battery storage developers, because there is an entire different market. I'm originally from the renewable energy market, so I've been building solar PV plants, and now we're building huge hundreds of megawatts of large-scale energy storage that can retain energy for 2 or 4 or sometimes even 8 hours on a day. And we actually see both markets are trying to creep to each other. So it's very interesting from my perspective, because it's kind of a young love that's starting to grow between two businesses that were previously almost alien to each other. Because what you're doing when you're building a large-scale energy storage facility is that first you need land, and second you need a very large grid connection, and it seems that those are also required for building a data center. And there's even plenty of opportunity to co-locate a battery energy storage system with a data center, or vice versa. So those two markets can actually work quite well to each other. On the business side, there is also multiple developments, because as a data center operator, obviously you're trying to focus yourself on operating your white space and how you're operating this on the digital area. Whereas a battery interfacing with the grid is exposed to all different kind of market mechanisms, buying electricity, selling electricity, working on balancing markets, frequency control systems, voltage write-through or black start capabilities, these kind of things. And to avoid confusing yourself or running into a point where you actually lose yourself in all these new opportunities, why not just work together with a good partner who will focus on the battery side and exploiting that part, while you can just work on building or running your data center business.
But if you look at the challenges with net congestion, and we talked about the constraint of power to develop new data centers everywhere in Europe, from a technical perspective, you see a lot of solutions that are sort of like already ready to deploy. can we, with building a data center, solve also the grid issues that we see in Europe?
Solving would be a very big word, but you can help, for sure you can. So inside the data center, it already starts, as you already explained, when you're building and developing an AI data center, so we're talking about high density, you're already starting to look at how do you integrate your internal power infrastructure, how do you integrate your internal cooling infrastructure. Those things start to become a lot more critical, especially when you're talking about AI training. The thermal densities of a typical GPU is now tenfold of what we had for a classical CPU. So the criticality of your cooling system is now increasing in an enormous way, because if you lose the cooling of that chipset, you'll lose it within seconds. So the cooling infrastructure, or at least part of it, also starts to become now no-break loads, which need to be included inside the UPS. So the UPS is becoming a vital part of your data center infrastructure, and it also needs to be considered that it needs to interface with the grid. So we're seeing that large-scale energy storage is actually very close to your loads. Then basically is the, let's say, adapting your load side or your grid load to meet the power quality demands of the grid operators. AI data centers have a typical habit of ramping up and ramping down their loads very, very quickly. You will run into power quality problems. So the grid operator will demand for you that you should help stabilize voltage. And if your loads can't do that, you will need other assets. Those technologies are there. So battery energy storage is there. It has already the capability of becoming grid forming. So you could use your loads almost basically to support grid problems from that point on. So that technology is there.
Pablo, if you hear this, and also with the wide portfolio, is that also something that you've seen already in maybe markets where AI is already ongoing? How to deal with these kind of characteristics that you're seeing to solve it with the solutions that you are providing?
So for me, the key success factor to answer to those challenges is about digitization. I mean, all that flexibility that we were talking about only will happen if we are able to manage the data, to have real data on real time, that are contextualized, that are unique data, and that we can manage them in real time, outside of the data center, integrated into the grid, but also inside the data center. So for me, it's fundamental that we increase the level of digitization in our infrastructures, because that is the only way that we can optimize the way we operate it, is the only way that we can increase the resiliency of the data centers, that we can overcome also the scarcity of talent that can manage and operate the data center, and also that we can apply AI also on the way we manage the data centers, applying for changing the way we maintain it with condition-based maintenance that can reduce the on-site visits and reduce the number of outages that can be linked to human interventions or an issue on a chiller or on a UPS.
And also be transparent and in terms of reporting towards governments what we are doing.
Absolutely. Regulation is becoming higher and higher, and then in order to get the real data that we can share and meet the regulations, we definitely need the data. So we need to extract them from the field devices.
I would look at it a little bit different. So we are talking a lot about power constraints, and we all know that cooling is a large part of power consumption in a data center. And we are talking about new technology like liquid cooling, but I'm not convinced that we are utilizing liquid cooling to its full potential. Right now, what we are seeing is, and I started talking a little bit about it earlier, that I thought, for example, liquid cooling will eliminate or minimize the need for mechanical cooling. We're seeing the opposite. We're seeing the opposite because we are forced to provide water temperatures that are well below where we could be to operate these chips. And I think there are multiple reasons. One reason, for example, is to put some safety margins in there, that if a failure occurs, that these chips not die immediately, as we talked about. But the other reason is that we're focusing on performance rather than on efficiency when it comes to energy consumption. And I think we need to take a step back and take a very close look at where we can find the happy medium between I want to focus on performance but also on efficiency. Because the grid is not getting better anytime soon, especially not in Europe. So every way we could find to preserve energy, to reduce energy consumption by minimizing the need for mechanical cooling, to my opinion, is something that we need to pay attention and take a look into. You mentioned data. I think data is another very important element because I need to ensure that the system that I put in place is fail-safe. A fail-safe system means I need to monitor it. Today, we have the ability to take way more information out of our systems to predict certain failures that could occur. I think we need to take all this into consideration in order to get to the point to drive our water temperatures up, but still meet the performance and the fail-safe operations of the system.
Definitely.
Perfect.
I mean, the equipment and the system need to be efficient, but also the way we manage those systems that are more efficient is going to be much more efficient if we use the data, and we, for me, they're totally interconnected.
We're almost through to time. I think we're through to time, but a final, so like 10 words. What is key for everybody in the audience to take with them to do? Bauke, what is the 10 words, short?
Less than 10 words. Embrace the flexibility and let go of the rigidity.
Excellent.
I would say also embrace modular and standardization and stop entertaining ourselves, because we are all engineers and we like entertaining ourselves in custom designs.
Very good.
Focus on getting most efficient liquid cooling designs and focus on performance and energy.
Thank you.
Thank you.
Perfect. Thank you very much.
Thank you, sir.
Yep.